Lesson 12.4, Law of Sines, for Honors Algebra 2. Alright guys, so for this lesson we're going to be learning two main things. The first thing is how to find the area of a triangle, knowing two sides of the triangle and the included angle. And also we're going to learn how to solve triangles using the law of sines. Alright, so for this first part, if we have a situation where we have a side angle side. So we know the two sides of a triangle and also the angle included. We can find the area of the triangle using these formulas. All right, so let me give you an example. So number one, find the area of ABC to the nearest tenth if necessary. So you guys will be using your calculators and just make sure you are in degree mode. All right, so to find the area of this triangle using the formula, the area is going to be equal to 1/2 the product of the sides, so 11 times 14, times the sine of the included angle. All right, and you just plug that into your calculator, and if you round it, we should get 62.3 units squared. All right, and that's all there is to it. So let me show you one more time. So this one, we have the area is equal to 1/2 times the product of the two sides times the sine of the included angle. You plug that into your calculator, round to the nearest tenth, and we should get 41.8 units squared. Okay, let me show you one where the picture isn't given. Okay, so number 4, we have angle A. So if you want, you can draw the triangle just to make sure you have what you need. So angles are always labeled with capital letters, and then the side lengths are the lowercase letters, and the lowercase letters correspond to the angles that are opposite. So if this is angle A, this is side A. All right, so C they give us is 4 centimeters, and B is 7 centimeters, and angle A is 20 degrees. So we do have a side angle side situation, which allows us to use that formula for area. So area would be 1/2 times the product of the two given sides times the sine of the included angle. All right, and that, if you type that into your calculator, gives you 4.8. This will be centimeters squared. All right, so why don't you give number 3 and number 5 a try. Pause the video, and once you have your answers, unpause it, and you can check your answers. Okay, so for the answers for number 3, I have 32.9 centimeters square. And then for number 5, I got 61.4 meters square. Okay, so that is our first formula to find the area of a triangle given a side angle side situation. Okay, now to the main event. We are going to be talking about the law of sines to solve triangles. All right, so it says here, you can use a law of sines to solve any triangle if you know the measures of two angles and any side opposite one of those angles, or the measures of two sides and the angle opposite one of them. All right, and here is our formula for law of sines. Okay, so we have sine of an angle over the side opposite that angle will be equal to sine of another angle over the side opposite. So those ratios will be equal. Okay, now this can get a little tricky because we actually have 3 situations that we can find ourselves in given right here. All right. And by situations, I mean in terms of number of answers we can have. All right. So there are some cases where, given lengths of the sides and given the angles, it's possible that we have a no solution situation, right? Where it's actually impossible for that triangle to exist. So it can look like that if our angle A is acute, or it can look like this if our angle A is right or obtuse. So we see that side A just is not long enough to actually form a triangle. All right, so that's one situation. Another situation is that we can get exactly one solution. All right. So how the lengths and the angles they give us work out, it's possible to get exactly one solution. Okay, so it can look something like those. All right. And then the third situation that we can find ourselves in is that we possibly could have two solutions based off of what they give us. So the two triangles they have here are this one. That's one possible triangle. And let me use a different color. I'll use black. It can also be this triangle. So those are the two solutions in that situation. All right. So we're going to be using law of sines to solve for the triangle. And when we solve for the triangle, we need to solve for all possible solutions. All right. So let's give this a shot. All right, so number 6, it says determine whether each triangle has no solution, 1 or 2, then solve the triangle, meaning find any missing sides, any missing angles, and then round to the nearest tenth. All right, so let's go ahead and see what happens here with number 6. All right, so for number 6, what we're going to do is we're going to set up our law of sines. All right, so we have sine of 48 degrees, that's angle A, over side A is going to be equal to sine of angle B, which we don't know, over side B. All right, so that is using the law of sines. And now we're going to solve. So I'm going to go ahead and I'm going to multiply or cross multiply. And then I get 11 sine of B is equal to 16 times sine of 48 degrees. All right, and then divide both sides by 11, plug that into your calculator, and you should get that sine of B is equal to 1.0809. Okay. So at this point, if you want to solve for B, you would have to do inverse sine. Since we don't know the angle, we would inverse sine both sides, and we would solve for B. And if you did that in your calculator, you would get a error or undefined. And that's because this is impossible. It's impossible for sine of an angle to be greater than 1. So if you think about what sine represents, it's the opposite over the hypotenuse. And since the hypotenuse is typically going to be larger or equal to your opposite, it's impossible for this ratio to go over 1, because that would mean that the opposite side is greater than the hypotenuse. So what this tells us is that this triangle does not exist. So there is no solution. All right. And that's number 6. Okay, let's try number 7. So number 7, we're going to do the same thing, and we're going to set up our sine, our law of sines. So we have sine of 34 degrees over 6 is equal to sine of angle B over 8. And if you cross multiply and solve for sine of b on your calculator, we get sine of b is equal to 0.74559 ... Okay, so now we know that we have at least one solution. Now, in order to find the solutions, what we need to do is we need to first find out what are the possibilities for angle B at this point. So if you do inverse sine on both sides, and so we're going to do inverse sine of 0.74559, we get angle B is 48.2 degrees. Now, your calculator gives you this angle, and this is actually the reference angle. All right. It is actually possible for B to be another angle, because we know from our previous lessons that sine is positive in the first two quadrants. So there is an angle that gives us sine B is equal to 0.74559 in the first quadrant, and also 1 in the second quadrant. But they both have this reference angle of 48.2 degrees. So for the first quadrant, that's easy because it's just 48.2 degrees. For the second quadrant, we need to do 180 minus that angle to give us 131.8 degrees. All right, and that is our second possibility for angle B. And if you don't believe me, you can go ahead and try it. Type in sine of 131.8 degrees, and that will give you the 0.74559. All right, so it's always going to be the first and the second quadrant with this reference angle. All right, so you do 180 minus that, and that's how we get this one. Okay, from there we have two angles now. We have angle A, and now we have angle B. So knowing that the sum of the angles of a triangle is 180, I'm going to do 180 minus the 34 degrees minus the 48.2 degrees to get our last angle, C. So we get 97.8 degrees. Or if we do that again, but with 131.8 degrees, we get 14.2 degrees. All right. And so the only thing missing now is side C. So to get side C, I'm going to set up again the law of sine ratios. Okay, so then I have sine of 34 degrees over 6 is equal to sine of angle C over side C. All right. And now for angle C, I'm going to use 97.8 and then solve for C. Okay, so then I have, you can do this all on your calculator, by the way. I'll just show you the work that I'm doing in my head. So then I have C is equal to 6 times sine of 97.8 degrees divided by sine of 34 degrees. And that gets me side length of 10.6. Okay. And if I do it the other way, or with the 14.2 degrees, I have C is equal to 6 times sine of 14.2 degrees over sine of 34 degrees. All right, and you plug that into your calculator, and hopefully you get a side length of 2.6. Okay. And that's what it looks like when you have two solutions. Again, for work, I do not require that you show this step. You can do that in your head. All right, let's go on to number 8. All right, so number 8, once again, let's set this up. So we got sine of 30 degrees over 2 is equal to sine of angle B over 4. Solving for sine of B, cross multiply, divide, we get sine of B is equal to 1. So B is equal to 90 degrees. All right. And since the complement of that is also 90 degrees, this is one of our one solution situations. So angle C, if I do 180 minus 30 minus 90, I get 60 degrees left for angle C. And setting up my law of sines again, I get sine of 30 degrees over 2 is equal to sine of C, which is 60 degrees, over side C. And so I get side C is equal to 3.5. All right. And that's what it looks like when you have one solution. Okay. Why don't you guys go ahead and try to finish off the page? So numbers 9 through 12. And once you're ready, go ahead and unpause the video and you can check your answers. All right, here are your answers. This is for number 9. There were two solutions. One would be if angle B was 64.3 degrees, angle C is 65.7 degrees, and side C is 40.5. Or angle B can be 115.7 degrees, angle C is 14.3 degrees, and side C is 11.0. All right, for number 10, this was no solution. No solution. All right, and number 11, this was just one solution. You can see my work there. And the one solution that worked was angle B is 34.0 degrees, angle C is 21.0 degrees, and side C is 9.6. All right, so for our last problem, number 12, our word problem, I drew a picture. So there's my lovely picture with station 1 and station 2, and we have the angles, and they are 5,000 meters apart. All right, so given those two angles, I could find the last angle using 180 minus 52 degrees minus 41 degrees to give me 87 degrees. And then I wanted to find the distance along the side of along the line of sight to the fire from the closer of the two stations. So I went to the side opposite the smaller angle, 41 degrees. Since the side opposite the smaller angle would be the smaller side, so that would be my x. All right, and then to solve for that, I use my law of sines, and this is my work right here. And I got 3,285 meters. All right. And that is it for the lesson.